Hello Physical Science, this is Mr. B, and we are going to pick up today with Section 2, and the title of this section is Energy Conversion, which we've kind of mentioned this in previous videos here about energy being converted from one form to another, and then Energy Conservation. So words look very similar, they have two very different meanings, as we're going to see as we kind of work our way through this section. But to start, again, as always, we have our example, and our example at the beginning, this one is, feel lucky that this wasn't your car. Here as talks about as a meteor traveled through the atmosphere in October of 1992, some of its kinetic energy, again its energy of motion, was converted into light and heat. And upon impact, much of the meteor's remaining kinetic energy went into smashing the rear of this car in the Peekskill, New York. So this car, again, sitting there, minding its own business, and it just got struck by a meteor. So and there's not much more blind bad luck than that. So again, you might just think of it as a crazy coincidence, but there's a lot of energy conversion and conservation going on during this process. So the first main question that this first half of this section is going to focus on is, can energy be converted from one form into another? And the very simple answer to that is that yes, energy can be converted from one form to another, and we're going to take a look at some different ways that can happen in real life situations in class, but we'll get a couple examples and we'll explain that a little bit more in this video as well. So that's going to be kind of the main overriding idea, is that energy can be in fact converted from one form to another. And so this process of changing energy from one form to another is called energy conversion. So this is a big important thing right here. The process of changing energy from one form to another is called energy conversion. And one example that they give is the striking of a match is a good example of how energy can be converted or changed from one form to another. So the first step is your muscles use chemical energy to move the match. So that's the first step. Your muscles use kinetic energy, they use chemical energy to move the match. And the friction between the match and the matchbox converts kinetic energy into thermal energy. So you're moving the match, so that's where the kinetic energy comes into place. And the friction between the match moving and against the matchbox, that's friction. Friction produces thermal energy, and then that thermal energy is then converted because the chemical energy is converted into thermal energy and electromagnetic energy in the flame. So I'm going to break that example down in class more tomorrow. So I think I do a better job. They kind of leave some steps out, but this is just kind of a good basic example of how the different forms of energy are converted again from one to the other. They're changed from one form to the other. And again, I will go over this example in class to make it make a little bit more sense than what they did right here, because I didn't really necessarily like the way they had this one set up. And then again, energy is converted from one form to another as this match is lit. So again, lighting a match is a very good example, kind of a very easy one to see all the different conversions that take place. But like I said, I will go over that one more in depth in class tomorrow. And so now, that's how energy can be converted. Again, it can go from one form to another. But now we also have the law of conservation of energy. And the law of conservation of energy states that energy cannot be created or destroyed. So I think you've probably heard that before at some point in your life. Again, energy can never be created or destroyed. And then just to add on to that, to go back a little bit, it can only be converted from one form to the other. So when energy changes from one form to another, the total energy remains unchanged, even though many energy conversions may occur. So no matter what you're doing, again, in that whole process of lighting the match, the whole amount of energy, again, it was constantly changing forms from thermal to kinetic to chemical to electromagnetic. Again, that was all just changing the energy. The amount of energy never actually changed. And in a closed system, so again, with nothing else acting on it, the amount of energy present at the beginning of a process is the same as the amount of energy at the end. So again, that's kind of like what we talked about with friction earlier on in the year. Again, as long as there's no other outside forces acting, with momentum, not friction. When we talked about momentum with the train cars earlier in the year, I said in a closed system, if there's no other forces acting on it, the amount of momentum stays the same, and that's the same with energy. If there's no other forces acting on it from the outside, the total amount of energy is going to be the same at the beginning of the process than it is at the end of the process. Again, it might change forms 100,000 times, but the total amount of energy is going to be the same. and then just kind of an example of how friction kind of can play a role in this, because friction is always present. So the work done by friction is going to change kinetic energy into thermal energy. So even though friction might be present, that's not going to change the total amount of energy that is involved in a process. So friction within machinery reduces efficiency, and we've talked about that before too. And then friction is a major cause of energy consumption in cars and factories. So one of the main reasons why cars and factories aren't overly efficient, again, I've heard that word gets thrown around a lot, is because friction is always present and we're always losing some of our energy to friction. And then friction is usually changing kinetic energy into thermal energy, and remember, thermal energy is associated with heat, so if things have more thermal energy, the hotter they're going to get. So friction, the more friction there's present, the more heat there's going to be. Again, we've probably all felt that in some real-life way, one way or another. And in many cases, another example of how friction can act, most of a falling object's potential energy is converted into thermal energy because of air resistance. Again, air resistance is just friction through the air. So again, friction is always present. It's not getting rid of our energy. Friction is just another way that our total amount of energy is transferred or is converted from one form to another. And then our last example here before we wrap this one up is that although speed skaters slide quickly over smooth ice, they're still slowed down by friction with the air and the surface of the ice. So again, they're putting in a lot of energy, and again, they're moving quickly, but friction is still there. Again, it is still in our energy conservation and conversion processes. So that's it for our first part of this video. Let me know if you have any questions.